Good morning, good afternoon, or good evening, depending upon where you live around the world. We're back into it, and I thought I would look at a SketchUp side of the dome in drawing, in this case, dihedral angles, these two lines in here, and how we get to achieve that. In the process, when I was creating these angles, I was noticing that when I was putting my arc tool on the surface, as I approached this point here where I wanted to generate the arc from, I would occasionally flop back between the two and my arc tool would be in the wrong surface. It's not an onerous thing itself, but when you're doing lots of them, you want to keep everything as efficient as possible. So thinking there must be a better way, I recalled that using the shift key can lock your tool into a particular orientation or position. Aha, I said. Does that apply? Why, yes it does. So in this case, I want to replicate these angles. So I hold my cursor on this plane here, this surface. I hit my keyboard, I hit the A to bring up the arc tool. Then I hit shift and hold it down, and it changes into this purple color, which means it's locked to this orientation, this surface angle. I can then click the point and then let go the shift key, and I can draw my arc as I want to, and it's accurate on that surface. You also look down in the bottom right hand corner and it's got 51.2 degrees. Aha, that's great. This is what I want to write here. Now, before we carry on to the dihedral angle, writing all these numbers down can be laborious. We have to go over, in this case I use the 3D text tool, not the text tool here, but this, and there's no shortcut to it, not that I'm aware of as a default. So I created my own. I just went up and went into the preferences and into the shortcuts, and I just made Shift T, T for text. I'm going to do the same for a protractor eventually, but I'm not too sure whether it's occupied by the Shift P for protractor, or whether that's already been allocated. We know P is push-pull, but the Shift P could be for protractor if you so wish it. Just speeds up the process. Now, back to this. We want to get the angle, the dihedral angle between the two surfaces. In fact, I suggest you go one step further and get a separate dihedral angle. I'll show you what I'm talking about. I'll hide this surface and I'll hide this surface here. You want the angle from the plane, or from this plane on this side and this side, because as you can see they're not the same. So when you set up your bench saw or your tilting router table, if you've got one, you want to try and get it as accurate as possible. And knowing that there is a difference of 3 degrees, you can build that in and create your strut with better angles. It means that if you've got rigid cladding like polycarbonate or alu-clad plywood or whatever, you can create the bevels that will allow the surface material to lay flat. How do you get these angles? Well, initially I was drawing lines off of the, say this line for example, and occasionally I'd get lucky and they would be not only square to the line but angled in a manner that's flush in this angle or surface angle of the plane itself. Now that wasn't always as smooth going as I would want it to, and when you're going to be doing a lot of them, you want the process to be as straightforward as possible. So I came up with this. Now you probably go, yeah, I know how to do that, Dave. Well, that's great, carry on. But for those that don't, be mindful that because this is a 3D model, but it's generated on a 2D screen, our eyes can trick ourselves, trick ourselves into thinking that what we've got is accurate and correct, where in fact when you start rotating it around you go, oh, that's nothing like it. So trying to ensure that the process is as accurate as possible and easy, this is what I've done. I'll just unhide everything. I will mark a line here. It can be anywhere. It's not necessarily the center line. Good if you can get that. And there's a reason why this is not as straightforward as you would think, because I can mark a line here now and I know that's the center point of that line, but when I use the protractor and hit shift, it doesn't pick this point up. So putting a physical line in the drawing allows me to reference it, and it will get deleted in short order. I can then use the arc tool to create an arc similar to these ones here that goes from one side to the other, and then from this known point go to the center of the arc. That gives me a line 90 degrees to this line and flush in plane. I repeat that. I'll just try and rotate this a little bit. My computer's a bit slow at the moment. I repeat that on this surface. I scribe an arc, draw a line down from our known point down to the center of the arc, and that gives me the line 90 degrees to the line in this plane and in that plane, which means I can draw this. So let's do that, shall we? I'll just get rid of this for a moment. I'll get rid of this because it transfers the lines from the other side. So if actually I'm going to have to unhide everything. It's a bit of a nuisance. I will unhide everything. So having this line here, I can create my arc, A, come to this surface, hit shift and hold it down, come to this point here, click, release my shift button, and it means that it's locked on this surface. I create my arc, and I know that if I draw a line from this point out here, it is going to be in the correct position. It's flush and plane and 90 degrees to this line. Now, can we make it even easier? Well, yes, we can. Let's do it again. So I'll just, and how do we make it easier? Okay, when we hit our arc tool, we notice that we've got 12 sides. If I hit 3, what's going to happen? So I'm on this surface here, hit shift, come down here, click, release the shift, come up here to any position. I've got 3 sides. I take my line tool and I know that that's flush and plane and 90 degrees here and flush and plane. If I can use say a 4-sided arc, is it any easier? Well, let's find out, because I know the answer. So I hit the arc tool, or A. I come and I'll put enter in 4, enter, hold it on the surface, hit shift, come to here, click, release shift, come here. I know straight away that that's the point where I need my line to join up with, so bingo. It makes it more clear and easier to see. You're not second guessing yourself when you've got a higher segmented arc or semicircle. So that's easy enough. We repeat the same process on this surface. I'll just get rid of this for a moment. So that's one line. I actually might get rid of that. I'll delete that. My computer's a bit slow. So I hit my arc tool. Yes, it's 4 sides. I can come there. I know it's on the surface. It's not flicking back and forwards. I could hit the shift key, but when there's a big difference here, you can notice the change. So it's not so much of an imposition. On the surface, come up here, click, click, and click, and now I've got the line that I need to draw down there. Simple. So we're finished, are we? Not quite. I like showing the arc, like here for the angle of the surface, and in this case here I like showing it literally with an arc. How do you do that? Well, the easiest way is to make a triangle, and I can get rid of these just to tidy it up. And now I can hold my arc tool here and it will generate on this plane. Not this one, not the purple one that I've hidden, but this plane. You want to make it even easier? Put your guidelines along here. So now when I hit my arc tool along this surface, I can come, that was, see here it flopping around there? That was a wee bit tricky. I hit it there, click. Now I can click anywhere along the guidelines to the other guideline, and I know that I'm going to create the correct arc, and then I can put my lines in and another line in when it gets ready. Get rid of that, and I've got my arc. When you use this arc, you may want to have a smaller section, segment size, and that's all well and fine, and I would suggest you do that. I retained the smoother arc when I was creating the original ones because I got comfortable with doing it and it was less of a problem, but initially you may want to have those lower numbers of sides so that's more clear. But you also like to see something that's pleasing when you finish the job, and I don't find these pleasing, whereas I'm going to have to unhide and then hide a few things, but bear with me. Hide that and hide, come on, hide that. Those smoother arcs do look a lot nicer in the drawing rather than these more the less smooth arcs. So it's up to you, but I like this version. If you get used to drawing your guidelines, it helps make sure that you intersect your lines in the right place. And you can draw them here, and hey presto, you've got your dihedral angles for both sides of the strut. Just as I have here. Not much in difference, only 3 degrees or so difference between each one. And that itself is another design issue, not one we need to touch on here, but the closer the angles are between all surfaces, the more symmetrical or smooth the dome will look. So you don't have abrupt angle changes or significant angles different from one surface to another. Okay, so that was the dihedral angle question and the drawing of it. I'll do all this again in a more condensed video or series of videos. These are the step-by-step as I come across them and think to add them type of approach, and why sometimes they will be more about SketchUp than the actual building of whatever, in this case the dome, we'd be concentrating on normally. Okie dokie, I'm going to go off and have something to drink, and I'll see you in another video coming up. Okay, bye.